Cengage and why Barton and Mick are so critical to kind of the things that we're doing in the operational space is because they're the hands that we're handing off our child to, right? And it's breaking down those walls of the fact that you're getting attached to the system by understanding the fact that there's automation that's going to make sure that you're not the one being woken up in the evening, that it's going to a good place in production, that it's able to function and carry on through the day without having to be sending 4,000 alerts that something's wrong. Because that's if an architect or an engineer actually enjoys their job, you get attached to those systems for those reasons because you don't want it to fail, right? No one wants to fail here, right? So when you kick something over the wall, you're doing another syndrome, right? So essentially operations has been munch housed by the development community over and over and over again. And they just sit there and they continually take it. It's like, here you go, here's this bomb. You just hold that. Didn't explode yet? It will. So, we're working through those scenarios, and a lot of the things that we're doing to break down those things relate to the tools. And I got told I couldn't talk about tools, but I'm going to. It's another concept that we're trying to enforce, and it's breaking down the snowflake scenario, right? We don't build snowflakes. We build a maze that is understood how to get out of, but we don't build snowflakes, right? We don't have unique systems. We don't deploy something different from dev to QA to production. So what we're actually going through is actually building the same thing that was in dev with controlled variation for the QA environment. And we're doing that with some of our tools that, configuration management, we happen to implement both Puppet and Ansible. We see them as conjoining things, not doing the same thing. And I think that goes directly to something Ryan stated. It's the fact that I don't take a hammer to screw in a screw, and I don't take a screwdriver to hammer in a nail. Right? So it's using the right tool for the right job. So a lot of those things are coming into play, and we're forcing our dev teams to get involved, and that made me take a step back and realize how wait a second, I'm doing the exact thing I'm telling them not to do. So that was a realization this past week with Mick and Barton. It's like when I tried to operationalize a good set of our tools, I was like, wait a second, I need to step back and actually get involved into this whole DevOps movement and actually get my tools integrated into the program, because they weren't. They were all like, oh, this is an exception because I need to get it done. And that's always where we are. Everything needs to get done. But if you don't start the program from the beginning, it becomes really hard to go retroactive. So.
Everyone can hear me? Yes? Okay, good. Thank you. So my name is Alan Zoll. I'm the VP of Engineering at Cloud Technology Partners. We're both a software and services firm. We were a services firm until about 2 years ago when some Select IT was decided to spin off and turn into a product. So a bunch of architects and services guys said, hey, this works, let's make it a product. Should be easy enough. Not really. So when we got on board, we built a small team, mainly software developers. We're looking at a single AWS instance. The beauty of this, when we were building the product for the first time when I came on, it literally took me 2 weeks to get the development environment and the product to build on a regular basis. So it was talk to Joe about getting this module and talk to Sam about the next module. Now we're a company that's going out and talking about DevOps, talking about software engineering, but we weren't practicing what we were preaching. We had very little to no test coverage. The test process was non-existent, and deployments could take a day to get through. So that was sort of what I was walking into. And I'm listening to some of my colleagues here talk about dealing with massive numbers of people, large processes, outages, potential outages and risks there. We started with the development team of about 3. So I'm coming more from the startup organization, where we can't afford operations people. We can't afford to do a lot of things we'd like to do, so it has to be homegrown. So along this journey, we now have documented our development setups. We've automated our build processes, automated our test processes, single-click deployments, not because we wanted to and because we were given a budget to do it, but because it was critical in order to get a product up and off the ground and out to the community. Excuse me. So I think I come from a slightly different point of view when I think well, 2 things in particular I wanted to comment on. One, while you can't do this part way, I don't think you're ever truly done with your development, your DevOps process. If you think you're done, then you've missed something along the way, and that's for sure. And the other thing is you can have snowflakes if you've got a plan for how to put them in a bucket and make something out of it. Because sometimes you have to do it at least once to learn what the problems are, and take those and actually build upon those and iterate upon those. And again, this is smaller startup, 6-person outfit going from this application to what is now out there and run. It's a static code analysis tool that's out there today. So just a slightly different point of view. Our journey took us 2 years to get here. It was very much an iterative process. It was not an overnight. It wasn't thought out and planned out. It was hit a roadblock, work on it, resolve it, and move on to the next issue at hand. So you're not getting those midnight phone calls that no one really wants to get. So that's, I know I'm making up for the time that we lost along the way, but that's sort of our story. Interested in hearing what other people's stories are, and more than happy to answer any questions when we get to the end.
All right, you guys can hear me, right? Thumbs up in the back, thank you. All right, I'll be short, I promise. Everybody wants to have more beer and hang out. My name is Jason Reslock. I'm a software engineer for Teradata, formerly Hadapt. I think we sort of bring, at least I'm bringing a little bit of a different thing, very much like you did. Coming from a startup that was recently acquired by an extremely large organization. I was and sort of still am the DevOps guy at our company, but prior, about 3 years ago, it was a startup culture. We had very much this build our own versus buy a thing, right? So you need something, go make it, get the devs to help you out, this kind of a thing, because we really can't afford to go buy whatever it happens to be. Really small team. We had some hard problems to solve. We make a product that has to be installed and run and tested on Hadoop clusters, real Hadoop clusters, so we had to go and spin them up, make sure that we could do that without taking a week to go configure distributed computing systems. It was very interesting. So we had all of that when I started about 3 years ago, and then fast forward to last July, we were acquired by Teradata. We had maybe 20 employees at the time. Now we have 10,000 employees to deal with. It's kind of a culture shock, to tell you the truth. But it's interesting because they came in and they saw some of the things that we were doing and said, "Hey, we haven't thought about that, or we haven't been able to do it. Please help us." So they're actually looking to us as the new blood to sort of to help bring them into the 21st century. It's an interesting, totally different experience. There's a lot of legacy infrastructure, though, I'm not going to lie. There's even more legacy process and legacy culture. Maybe that's a nice way of saying people that have been there for too long. But there's a lot of that. There's a lot of, we've been doing this way for 25 years. If anybody knows Teradata, they're a spin out from NCR. They've been around since probably before a lot of you guys were born. I believe 1979 was when they were founded, so they've been around for a long time. So anyway, we get to show off a little bit in the current state, right? There's a lot of different engineering organizations lots of products, separate engineering organization for every single product. They're all coming to us saying, we need to look at how you're doing things, please help us. Very, very cool. You know, and what we're looking for the future, we're trying to bring everybody on, so we sort of conquest mentality, right? The more people we get, the more momentum we build, bringing everybody on, maybe not doing it exactly the same way, but at least have a framework, make sure that people are doing the same things, you know, automating, doing things the right way, and you know, continue to improve, hoping to even do this DevOps center of expertise, which I don't think that you could get away with unless you were in a very large organization. Right? Very much like the DevOps team. Right? You don't have the center of expertise, even like you don't have that idea or concept if you're a startup, because the center of expertise is one guy, right? So yeah, so that's it. I know I'm also making up for last time, so I'll let you guys go for it. All right.
Thank you. All right, Kevin?
Me?
Yep, you're up. I think there's a chair in here.
Well, I pushed it.
Oh, I squeaked the slide. You can even move this chair.
Give myself a countdown. 8 minutes, right?
There's like 18 timekeepers, don't worry.
Okay.
I read they'll slap, they'll raise their hand.
not to look at them.
I know. He's looking over. Like, let us go. Why are they counting down on their fingers? We're adding time now.
All right, we're a small company, so talking about kind of big process problems isn't really
Introduce
something.
yourself.
What's that?
Introduce yourself.
Oh, sorry. Kevin Gilpin. I'm CTO of Conjur. We're doing access management, audit, secrets management, and comprehensive kind of security play for cloud and DevOps. So we build and deliver a virtual appliance. So we're not a SaaS. We don't have like a big kind of manage a platform infrastructure type of problem. For us, DevOps is about like building and shipping these appliances. And we build for a variety of platforms. We try to obviously build and develop with as much, durability and testability and diversity of platforms that we can roll out and support. So that's really the objective for us. Let me jump around a bit. So I'll talk about CI, and our CI is Jenkins based. And Jenkins, like a lot of tools that we use, is fundamentally a fully programmable platform. You can use it to do whatever you want. And a lot of developing good processes is figuring out what tools are right for the job and what tools not so much. And that's been mentioned here before. So we had Jenkins working. We'd done a release or two. We had one stack to support, and over time, things were starting to break down. Reliability was poor, slow, hard to reproduce things, and then we had a real kind of AWS meltdown where we lost a bunch of stuff, and that really prompted a sort of self-examination. And Dustin joined the team about the same time, and he was like, this really needs to come under some management, and he was totally right. So, that prompted us to rethink what we were doing, and one of the things that I really want to talk about, not just now, but kind of going forward, is how I think there's a little too much emphasis on automation. And automation is great when you have a bunch of really stable and reliable building blocks, and then you can automate them and make them even better. But really, if you don't have the right building blocks, kind of rushing forward to automation just ends up sort of causing you some pain. Even if you're a conscientious software engineer and you understand that like big monolithic functions are bad and not testable and should be refactored into components, you can still end up building systems in your sort of ops, DevOps sort of sphere that don't have those type of characteristics. And so, it's important to think about durability, componentization, reliability, whether your developers are able to work efficiently with the process or they have to like debug stuff inside the production system, whether the system's transparent and easy for people to understand, or not. And the solution for us was to really re-engineer our Jenkins system with an eye towards separation of concerns. So all these things that were kind of mashed together within one system really needed to be teased apart in order to give us these sort of foundational building blocks so that we could independently build and test and version and promote the foundation image, which we built with a ton of Dustin's assistance, to verification of artifacts. Deployment is not the same as build and has different requirements for access management, audit, notifications. All these things that we had that were smashed together really needed to be separated. One of the things that we did at the beginning was to bring sort of a foundation image for our build under strict management of configuration management. So this is basically the stack that we chose for our build cattle, replacing our old build pet, including some tools that I'm not allowed to mention, but you know what they all are. Another thing that we spent a lot of time on.
Slideshow mode? Do the QA. Do the QA.
What's that?
Slideshow mode.
Yeah, so they can see it.
So you can see. All right, yeah, this one's tiny. It's got 10 things on it.
We'll post it after.
I think there's an important analogy between, if you guys are familiar with like the Heroku's 12-factor application, where they look at how to make things portable and containerized. Before everybody knew what containerized was, and refactoring our build jobs to follow these kind of maxims of separability was really resulted in something that was flexible across development to production, much easier to version, easier to link components together in novel ways. For example, when you want to try a different database version against your build system, if you have these pieces decoupled, that gets much easier. There's a lot of other content behind here, but it's not 8 minutes of content. We're very, so secrets is a core capability of ours, and what we do is we put, instead of putting secrets into source control, we put these descriptor files in. And a descriptor file essentially maps a secret in your secret store to an environment variable. And then all of your scripts and jobs and containers and whatnot are all written to accept secrets from the environment. This is something that we certainly borrowed from the 12-factor manifesto. And this gives you something that you can then commit into source control safely as a descriptor of what secrets are required. And it eliminates the need for people to hunt down secrets and spend 2 weeks finding the guy who has the password or the SSH key or what have you. So this is a real efficiency win. We have a policy of SSH accesses always with your own private key. So again, if you don't have access, it's because you don't have access. The answer is not to go and find the guy who will email you the pen to get into the thing that you want. Another efficiency win, because it just reduces the scope of your hunt for a solution. So here's an example of troubleshooting a secrets problem. We had actually retired a website that we decided to resurrect again. It turned out that we had taken the secrets that were needed for that and archived them. When you go to run the build job, you get permission denied. And because we have a system that does access management on secrets, really the only solution is to figure out how to get access. Once that's restored, it's going to work. It's a much more simple and kind of streamlined troubleshooting process. So what we've been able to do is reduce Jenkins from the mission critical, nothing happens unless Jenkins is humming along system, to something that makes working components go faster and better. We're much more able to quickly recover from transient issues in CI by sort of blowing away the misbehaving machine and starting over. This happens pretty often. We can emulate the same type of processes that are happening in Jenkins manually, because everything that's needed to run a build job is in source control. Everything from the base image to the secrets to the containers, you can run everything locally. We separate between building artifacts and pushing them out into the world, and I think that's something that people should really take seriously. And it's frictionless to move around between the CI system and development. If you have a CI problem, you can debug it in development, so you get a lot less churn and hacking like on the live CI system to fix problems. So there we go.
Thank you.
Thank you.
Alright, so that's our talks. We're going to open for questions now. So, direct them to the panel.
We want to pass the mic so we can hear questions.
Yeah.
Better. I think
Hey.
that's too.
All right, so we have a couple mics here. We feel that the real value play here, guys, is for you to be able to kind of, pick some of the minds, and take some specific case examples that you have in your own shops, and you can obviously talk tools, talk technology stack, anything you want. But this is where our main value piece wanted to come out. So feel free. You guys pick the panel apart. Ask whatever questions you want. So whoever is up.